Today we'll talk about angles. We need to start with definitions. The first one that we have is a line. A line extends forever in two directions. You can see that by the two arrows. Really similar to this is a ray. A ray starts at a point and extends in one direction. So if it has two directions, it's a line. If it has one direction, it's a ray. When I put two rays together, or I intersect two lines, they form angles. You can see this one that I labeled beta, where the two rays came together, I form an angle. And in the line, I have 1, 2, 3, 4 angles formed by the intersection of the two lines. When we want to indicate what angle we're talking about, it's important that we name them in a way that we can all understand. If I were just to refer to the angle B, well, am I talking about a top angle? Am I talking about a bottom angle? Or am I talking about the angles if I put them together? So to be clear, we're going to name an angle by giving 3 points. Let's say I want to talk about the top angle. The top angle is A, B, C. B, the point where the two rays intersect, is called the vertex. As we write the angles, it's important that we always put the vertex as the center point in our description. So we may write angle ABC. We could also choose to write angle CBA. So starting with A or starting with C really doesn't matter as long as you put the B in the middle. If I wanted to instead talk about this lower angle, then I would want to say CBD, or I could say DBC. Again, I want to keep that vertex in the middle so I know that that's where the two are going to come together. Say we want to talk about this really big angle that's formed by these rays. B is still going to be the vertex, but this time I would want to say either angle A, BD, or I could say angle DBA. One's not more right than the other. It's however you choose to say it, as long as you put that middle point there for the vertex. So we're going to have a bunch of different types of angles that we need to get through. Each of them are going to be measured in degrees. The first one we'll talk about is a line. Lines are always straight lines, but when we want to say that we're talking about the angle, we call it a straight angle. This will have 180 degrees. Say we kind of cut that in half. Cutting in half gives us a 90-degree angle. 180 over 2 is 90, and we call this a right angle. Notice this box. This box or square is used to represent a right angle, so sometimes you'll see that little box without the 90 degrees and you're just supposed to know that's what it means. Two other types of angles that have to do with the measure are acute and obtuse. Acute are little, so things that are less than 90 degrees, we call that acute. Obtuse is big, so anything between 90 and 180 we call obtuse. So now let's go back and just find the measure of some angles. So let's start with ABE. So I'm looking at this graph and I say I'm looking for ABE. Well, I don't have it, it's not written in, but what do I see first? I see CBA forms a straight angle. So straight angle has 180 degrees. So that says if I add 50 and 115 plus whatever ABE is, I should get 180 degrees. Well, I know 50 and 115 is 165. Which means I just need to subtract. And of course you can grab your calculator if that makes you happy. Then you can do 180 minus 165 and you'll end up with 15. I'm going to write that 15 twice. I'm going to write it first up here where it says A, but I'm also going to put it on the graph because it's going to help me answer the rest of the questions. So question 2, or I could call it B, says DBA. So if I look, I have D, comes down to B, and goes over to A. So notice that takes the 115 and the 15. So we're adding these together. It says I have 130 degrees. Similar to that, let's look at CBE. So C starts on the left, goes over to B, which is my vertex, and up to E. So this also is a combination of two angles, but this time it's 50 and 115. That together gives me 165. Let me give you a couple more names of angles. Complementary angles come where two angles come together and form 90 degrees. Again, you can see that little box to say that's 90 degrees. And then supplementary angles have a sum that come out to be a straight angle, so they're at 180 degrees. Let's find the supplement of 38 degrees. So first thing I'm thinking about is supplement says I'm talking about 180, and I want to subtract 38. So 180 minus 38 gives me 142. Again, put the degree up there so we know we're talking about angles. Similar to that, I look at the complement of 63.7. Complement tells me immediately, let's start with 90, then let's write minus 63.7. And that gives me 26.3. One more type of angle, called a vertical angle, happens when two lines intersect, and the opposite angles are going to be called vertical, and those vertical angles are going to be equal. So let's look at what that looks like. Okay. So here are two lines intersecting, and let's look at our first pair of angles. Right, these angles look horizontal, that's absolutely fine. What we're looking for is they're opposite each other and they're formed from lines intersecting. So these angles 1 and 2 are going to be equal. I also have angles 3 and 4 that are opposite each other, so angles 3 and 4 are also going to be equal. Let's kind of put this all together and start solving. So here's our first two examples. I have first 44 in A, and then I have 71 in B. To start solving, we want to think first, what kind of angle do I have? So with 44 in A, hopefully you're thinking, oh, these are vertical. With vertical, I know that they are equal, so immediately know A is 44 degrees. With 71 in B, this relationship is complementary. That says they add up to 90 degrees. So if I do 90 minus 71, which is 19, that's the measure of B. So why don't you try? Pause me for a minute, quickly do these, and then come back and let's check. All right, so let's see how you did. Once again, I have vertical angles. The 128 and E are going to be equal. And this time, the 70 and the M are supplementary, so I need to subtract from 180 because these form a straight line. So 180 minus 70 is 110, and that's my measure for M. The next one, I'm finding the missing angles. I have 3 of them. So I have X, Y, and Z. Where would I start? I would start with the vertical and say Y is 139 degrees. Then I can either look at X or I can look at Z and see that there's this line, right, where they're going through and they would make 180 degrees, so these are supplementary. So to get the value of X, I can do 180 minus 139. This gives me 41 degrees. X and Z are vertical, so I immediately know that Z is also 41 degrees. So why don't you try one just like the one we had, pause me for a minute, find U, V, and W, and then come back and check. So just like last time, I would start with the vertical angle, which would be W is 73 degrees. Then I could go on to U or to V. Let's say I go to V, and I say it's 180 minus 73. Well, 180 minus 73 is 107. If V is 107, U is also 107. In this next one, we're finding the measure of angles, and let's make sure these lines appear the way they're supposed to. They came out a little light. So to start, we're looking at angle AEB. Let me mark it. What do I notice? I notice this is 90 degrees, and I have 23 already. So I can do 90 minus 23, which gives me 67. Anytime I get an answer, I like to go ahead and write it down so I can see it and hopefully use it later. The next question says, look for DEF. Well, immediately, that DEF I can see is vertical from the angle we just found in part A, so this will also be 67. The next one says, find angle CED, right here. Well, CED is opposite of angle AEG that we had from the beginning. I know this one is 23. And then finally, CEB. Well, CEB, we can look at a bunch of different ways. First, let's say, where is it? It's right here on the graph. I'll put a bunch of arcs on it. Partly I can say, well, I know there's this line that goes CEG, and I know this part was 90, so this part should also be 90. I could also say this was 90, so FEG was 90, and that's vertical, right? Bunch of ways to get to the same thing. Hopefully you can just see it. And the next one, it also says find the measure of the angles, but we're given a little hint ahead of time. We're given that angle 1 and angle 2 are equal. So to start, I have 114 degrees on this outside along with the 1. So the 114 and the 1, that forms a straight angle. So angle 1 will be 180 minus 114. This gives me 66. So let's write that angle 1, I'm going to write it underneath because I don't think I can get it in there. Now, we also know angle 1 and angle 2 are the same, so let's go ahead and write up here that angle 2 is 66. Well, what does that say? It says, well, if I wanted this angle over here as well, which I kind of need, it would be 114 degrees. So once I know 2, I know this outside one that we didn't label, but that's okay. And how is that helpful? Well, because that forms a vertical angle with angle 3, and now I know angle 3 is 114 degrees.